Today we're going to talk about formulas. More specifically, we're going to talk about oh, extended, or sometimes called expanded formulas. We're going to talk about condensed formulas. And then we're also going to talk about line angle formulas. So these are all different ways that we can represent a molecule in 2 dimensions. So let's start with our expanded. This looks a lot like a Lewis structure. You've probably seen stuff like this. Let's do butane. And butane looks like this. It has 4 carbons. And then at the ends here, we have 3 hydrogens. And then we have 2 hydrogens on each of these inner carbons. So this is what's called the extended or expanded. Now we can condense this. Let's condense this down. And when we condense it, what we want to do is write it in a way that someone can look at it and understand what this molecule looks like without having to draw it out. So what we do is we say it is CH3. We start over here on the left, and we say CH3. And these 3 H's, when you see CH3, you can really kind of think of it as an end, because carbon only has the capacity to bond with 4 other molecules or elements. And so when it has 3 bonds already, and it's in a carbon chain, it's pretty much going to be at an end. So we have CH3, then we have CH2, then we have CH2, and finally another CH3 at the end. Sometimes you may see this written as like CH3 and then in parentheses CH2, 2, CH3. But other times you might see it written out in the longer form like this. And now let's talk about line angle. So this is a way of representing this molecule very, very simply. Pretty much we're going to represent it by a line. And the way that we're going to do that is by making each of these carbons either an end or a bend. And I'm going to put LA here to mean line angle. So trust me on this, we're going to start and then you'll see. So we have 4 carbons in butane. So let's start by making one of them here. And we're going to connect it to another carbon. Then we're going to bend this down. So we're not going to continue up. It's always going to be a bend like this. That's our 3rd carbon. And then this is going to be our 4th carbon. So without these dots, this is what it's going to look like. This is what you're probably going to see is something like this. Or maybe even a little wider. I usually tend to draw them a little steep. So this is more like what you're going to see in a textbook, and this means butane. And what we know from this is that every end or every bend is going to be a carbon, and then these hydrogens are inferred. So we see this carbon here only has 1 bond, right? So we know it has to have 3 hydrogens on the end. This carbon here has 2 bonds. So what we know is that it has to have 2 hydrogens here. And if we move on, we see this one has to have 2 hydrogens, and this has to have 3. So it's a really simple way of representing these molecules. Now let's try another one. So let's go ahead, we're going to try this with another molecule. I'm going to draw it out for us here. It looks a little bit like this. And this is called acetaldehyde. I hope I said that right. So here is our expanded formula. This is basically our Lewis structure. So how can we write this into our condensed formula? So we start with the end, and we know this is CH3. We're going to follow with our next C, and then what we do is we indicate that the C is connected to the H, and then that the O is also connected to the C. Because when we put this O after the H, it indicates that it's also connected to this carbon, as is this oxygen, or this hydrogen. Whereas if we wrote it like this, CH3COH, what we would be saying is this oxygen is connected to both the hydrogen and the carbon. So when you have something, a carbon specifically, that is connected to more than just hydrogen, the hydrogen is always going to come first in the condensed structural formula, and then followed by whatever else is connected. And this indicates the proper alignment of this. Now, another way that you could have wrote it is kind of fun. It's kind of weird. It's CH3C with a double bond to O, H. So that way you really very clearly indicate exactly where that O is. So let's go ahead, let's turn this into a line angle formula. And so this only has 2 carbons, right? So we know we are only going to have to hit 2 points. We're going to connect them by this line. But then what happens? We have this oxygen. What do we do with that? So what we're going to do is bring this up into a double bond to oxygen. And so this is going to infer that this hydrogen is also connected to this carbon here, and that there are 3 carbons here. So really what you can see, you're going to see something like this. And that's the same as saying acetaldehyde. So there's one more thing I want to review here, and it's the different structures that you might see within these different line angle formulas. So let me draw one for you that tripped me up at first, and it looked like this. Now, that would trip you up too, I'm sure. And what this is neopentane. And how we read it is that there's a carbon at every end and every bend. So here, there are 5 carbons. So we have 1 carbon in the middle, connected to 4 other carbons. And then all of these have their own, active and fulfilling life with hydrogens. So each of these 4 carbons is going to have a fleshed out octet with hydrogens. I can't fit this over there. So that's what that's going to look like, neopentane. And so now let's do another one, kind of more traditional what you might see. So let's talk about benzene. And benzene is C6H6. And how in the world do we do that? So we're going to start by making our structure. 2, 3, 4. Oh no, I put too many. Okay, that's a stop sign. My bad. So here we go. We're doing a hexagon. That's awful. Oh my gosh. Let's try one more time. We can do this. We might be able to pull one up in shapes if I can. So let's use the bonds, or let's use the graph paper here. That's still terrible. All right, it magically appeared a hexagon because I had to turn off my recording to get ink to shape to work. So this is what benzene is going to look like. Benzene has 6 carbons, and so when we see 6 carbons, we're going to think this ring because we have 1, 2, 3, 4, 5, 6. Now, if you notice, we only have 6 hydrogens, and each of these carbons only has 2 bonds. So if we were to fill this out and put a hydrogen on each of these carbons, we're going to have a lot of carbons with not enough bonds, with unfulfilled octets, because they're only going to have 3 bonds each. So what happens is that we need to get some double bonds in here. And so let's go ahead and put one in here. So now this carbon has 3 bonds, which means it only needs to bond with 1 hydrogen. Now this carbon has 3 bonds, so only needs to bond with 1 hydrogen. Let's put another double bond. This carbon has 3 bonds, only needs 1 hydrogen. This carbon has 3, only 1. And so then let's put our last double bond. So that is what benzene is going to look like. It's going to have a hydrogen coming off of each side, and it's going to have these double bonds. But if you think about it, this can have a lot of different resonance structures. These can all move. So you might see benzene with double bonds on different sides than you're used to. And sometimes that's why people denote this, instead of having these double bonds written, they denote this as, and I'm going to turn back on my ink to shape because we all know my first attempts at a hexagon were terrible. So sometimes people do this and then they put a circle in here. And this can be benzene as well because these double bonds can constantly shift around, and in its resonance hybrid, it's a little bit murky, where those actually are. And if they actually are, what we see is actually kind of a bond and a half, pretty much, or some kind of bond like that in this inside of the benzene hexagon. So just know sometimes it can get a little bit funky like that. You're going to see a lot of hexagons. That's where these line angle formulas really come into play. And let's do one more. And it's going to be, we're going to do norepinephrine. Norepinephrine, which is a chemical in our body, so that's kind of cool. And this formula is C8H11NO3. Oh, N. No. Okay. We got it back. Okay, so it's C8H11NO3. So the first thing that we're thinking here is that we need to make a carbon ring. And so that's going to take 6 of our carbons out of play. So here's our carbon ring. And then we still have 2 carbons left over. So what's going to happen is it's going to come out. This is going to indicate 1 more carbon, and then down, indicating 1 more carbon. And so then we have our H's, right? We can pretty much fill those in, but we also have NO3. So we know that N is going to come over here on this side.